Okay, so a couple of things since the last video is already a while back. So let's remind where we left off. So the last thing we wanted to do was to write a startup script, not a startup script, a script for backing up um, ZFS snapshots, archiving them, and sending them to S3, to Amazon S3, and also do some additional stuff like deleting the snapshots. Yeah, and we want to do that automatically, so we want to run it from cron. And yeah, so I already did some. Let's exit from here. Did some setup. Let's quickly go into this directory and see what we have here. So I already set up a Vagrant machine, a virtual machine, and already prepared a backup, a test file, and wrote some tests already. So, but to see how I approach this. So my first approach was okay. Sorry. My first approach was okay. So I don't want to test all this on the actual production machine where the script will be run, but instead I was looking for Vagrant virtual machines. So the requirements for them were they had to be running ZFS and and FreeBSD, just like the production machine. So I can work on the Vagrant virtual machine, and it will be exactly the same steps required for me to set the whole thing up on the production machine. Basically, what Vagrant is for. So yeah, that's that. Mm. And then my second approach was after setting up Vagrant, what tools or maybe first how the script has to work and what are its requirements, and from then figure out what libraries, what frameworks to use. Yeah, so this is basic markdown file I've written for what the script will do. So in order. So first it has to get all ZFS file systems because you want to back up all of them. And then get the latest snapshot of every of those file systems, because what I originally planned to do incremental backups with the ZFS. What was it? Let's quickly SSH into this machine. ZFS. Right, ZFS send -I, and then do from the first snapshot to the second snapshot, do the increment. But basically, this requires a lot of, or not a lot of, but actual some more. You have to basically every time you run the script figure out what was the latest snapshot already uploaded, which you can do, of course. But it's a bit tedious, and in case of restoring, you basically have to unroll the whole thing, because you would have one full snapshot or full backup, and then you have to like get every incremental snapshot and unpack them, and up to that point where you want to restore from. So and basically also the more you have to do with the more you have to deal with, like, figuring out what's the latest snapshot. There are like I can see some potential vectors for failure, like what if you back up to the S3 bucket out of the usual order, not from your script, and then everything is messed up and the script won't work anymore, and so on. So I decided I will just do full snapshots, full backups to S3 every, let's say, every week, and before every before and maybe after every big like installing new software like Samba, for example. I've planned to do that in the near future. So yeah, that's that. So we won't have to deal with incremental snapshots and so on. We just back up the latest snapshot. So for that, we obviously have to know what is the latest snapshot, of course, for every of these file systems, and then archive them, right? Because we will be paying for the not much though, but we will be paying for the storage on S3, and the smaller the snapshots, the better for us. So we will use XZ for that, or LZMR, and then afterwards we have to send this archive obviously to S3 um, and delete the archive, because we don't want to have it lying around on the file system, because you the next time you do a snapshot, you will be obviously this huge file, or this file which contains the whole file system, will be a snapshot as well, and the next time your snapshot will be twice as big, and it adds up. So we want to delete this archive immediately, and no matter if the script was successful or not. And after that, also delete all outdated snapshots with the zfSnap -d command. So remember, we're using zfSnap to automatically create some of these snapshots for us. So if I do ZF on the production machine, a ZFS list -t snapshot, there are a lot of them right here. And if I want to, and this means they are valid for 5 days, and obviously we don't have 2015 anymore. So if I run zfSnap -d now, those will be deleted. So that's what the script will be doing for us. After it did is it's sending and archiving and so on. So there are no like race conditions, or doesn't have to bother that that the snapshots are not there anymore. Okay, and then send a basic summary to us via mail. So we don't have to check every time, okay, how was the script successful, and how much space, how much storage do I have now on S3 and so on. Yeah. So based off this specification and requirement, we can now think, well, I already did this. I was thinking, what will I be using for that? So my original plan was to use just the AWS CLI command line tools. But the better approach, I think, is to do it all, because this will be you can basically do it in Bash just fine, but I will be using Python for that. So because it's a little bit more complex. So what I figured out I'll be using is first a library called Wire, which is basically just a wrapper around the ZFS command line tools, but it does a really nice job of the parsing of the snapshots. Like it uses URL parsing instead of like regex, what was regular expressions, was what was my first idea when I was thinking, okay, how will I be figuring out what are snapshots and so on. So it basically comes with these with a few functions which are very nice. So I decided to use this, and also use the Boto 3 official Amazon Python SDK, so AWS SDK. So yeah, so we ditched the command line tools for SDK, Python SDK, which yeah, I think it's okay. Um, and then I will be using Mandrill for sending the mail, which is really nice. I think also they have an official SDK. It's really has really nice documentation, and I also use it for another project. I yeah think it's really good. Okay. Mm, so what did I do after I figured this out, or basically in the process between, okay, I have these requirements, and I have and there are some tools that I might want to use. I obviously, on not obviously, but one idea which comes to mind is to write tests for that. So basically not for the actual implementation for our backup script, but for the tools. So see how they behave. Can they do what we want from them? So, and are they useful for our script? Can they fulfill our requirements? And that's what I already did here. There are some test cases, just plain unit test from Python. I went step for step, so get all ZFS file systems. We do that with Wire and ZFS and the ZFS module it provides. And then get the latest snapshot. ZFS Wire can also do that for you. Basically, you can call it with yeah, I won't explain it all, but you basically do a find write on an empty string, which is equivalent to like a ZFS list with an empty string, which will or not with with that, but without any string, right? So it will give you all file systems there are, and or maybe I should do it on the Vagrant machine because I have to have it open as well. So if I do, I have this is my Vagrant machine. So if I do ZFS list, I can use ZFS list on the Vagrant machine as well on the VM. So yeah, so it's basically ZFS list without anything else, and then you can do can get its snapshots and -1 to get the latest snapshots and .name to get the name, obviously. So that's that, and then archive the full stream. I also wrote a little test for that, which I will just do with sub process and shell equals true, because we don't have like we have sanitized input, so we can use shell equals true. And basically what this comes down to is a ZFS send. I can just demonstrate it here. So ZFS list minus t snapshot. So that's all our snapshots. I already did some testing. So let's, for example, do 0 to temp. So it's a ZFS send with this stuff and piped into XZ, which redirects to like blah blah blah, basically this name, archive .xz. Okay, and if you do ls, we have this archive, and and the test runner also deletes it right afterwards. So yeah, that's basically the archiving part. And then send the archive to S3. So we have to test Boto with a few tests, because it's not that simple actually, because it's an SDK for all the Amazon services, and there are a lot of Amazon services. Okay, but yeah, I figured it out. It's not, you have to they have a nice documentation basically, so you can figure it out in a reasonable amount of time. So okay, and after that we have to delete the archive from the local file system, which is not not that hard using Python. So I didn't write a single or a separate test case for that, and delete the snapshots. We will just run this command from Python with subprocess. Yeah, and then the sending email part is done with Mandrill, and they basically have this huge example on their page if you go to their documentation, which is really clear. You just do initiate the client with your API key, and then you can send a message or create a message first with a lot of parameters. You can send images, you can send whatever you want, what you ever can do with mail, and then you send the message, and yeah, so it's pretty straightforward, and it actually works. So okay, and then the last requirement was how many space is used on S3. So I didn't write a separate test case for that, but I looked a bit into documentation and what other people try to do that. It's basically, you have to do it the hard way. Basically, you have to iterate over the keys, over the resource keys in Amazon S3. So basically over your files which are stored in Amazon S3, and get the size of each. So there's no like get the size of your bucket type of method, unfortunately. So and how big was the created archive? You can just use the get size or the stat function provided by OS, by the OS module, or os.path module. So yeah, that won't be a problem as well. So we have figured out how to implement all these requirements using or writing a few tests, and now we can begin with the actual implementation of the backup script itself, and then and write tests for this as well. So that's the part we will be doing now. Yeah. Okay, but first there's something else which is cool, or which I just discovered, and which I want to show you. But first, let's check that all the tests regarding the actual testing the actual backup script fail, and the other still pass. So we have 5 errors because we have some more asserts in the free tests. So, but that's yeah, that's that. So we have the tests fail because obviously there's no implementation yet. So what I wanted to show is basically let's take that here. Wait a second, because I just was doing some debugging, and obviously I'm doing this in a Vagrant machine, so I can't just in PyCharm Community Edition, I can't like set a breakpoint here or here, and when I run it, because obviously this isn't, it's just a synced folder. This folder will get synced inside the virtual machine, and yeah. So the nice thing which actually exists and which I think is really cool is remote debugging, and yeah, so that's that. But for Vagrant, and there's also, if you type in Vagrant PyCharm, there's a Vagrant, where is it here? Yeah, you can configure remote interpreters. That's really cool, I think. So okay. So we are in PyCharm professional now, right? So okay, let's figure out how they want us to do this stuff. It's enabled, right? Okay, the Vagrant is enabled by default. Let's check that again with Java module. Vagrant. Right, okay, the plugin is enabled. That's nice. And folders on the following are added to the system. Okay, configuring remote. To configure remote Python interpreter in the project interpreter page of the settings dialog, click this stuff in the drop down. Okay, so no. Wait, isn't this somewhere here? Let's check that again. Maybe wait. Here? No. Oh. Project. No. Oh, so many options. Okay, in the project interpreters page. File settings, project interpreter. Okay. File. There. Project interpreter, right? Here. There it is. Nice. Okay. So there's that. The two interpreters I have here. Here at remote. Vagrant. Okay. Vagrant instance folder. Vagrant instance folder. Okay, so it's the folder of where the Vagrant file is, right? So it's in my case it's here and there. And the Python is located in which Python 3? User local bin, obviously. FreeBSD, everything is under user local bin. Okay. Let's see if this works. But can't be established. Yeah, right. Seems to work, right? Nice. Okay, and then let's just apply, right? Okay. Okay. Check. Oh, right, because there is no because actually for the script to run I have to, like I already wrote here, to set some environment variables which I haven't. So but whatever, for the sake of demonstrating, just quickly let me comment this out and do it again. Okay, it's a bit slow, I have to admit. Okay, there's permission denied, but it actually works, but I haven't got any breakpoints. But maybe I have to do like this, right? Oh, wow. Okay, now I have a nice debugger inside the Vagrant VM. Okay, I didn't even know that it can be this beautiful. Okay, nice. So that works as well. So I will begin implementing the actual backup script now. Okay, so I've finished the implementation of the backup script, but I haven't written any unit tests for it, so I don't know exactly if it's working or not. But I covered all the requirements, and I, at least in the main, tried to like mimic the flow of our requirements. So what to do first. So one thing I actually forgot in the requirements was obviously check if the configuration is right. So what I went with is this kind of usage. So the confidential data like your AWS API key or Mandrill API key has to be provided as not on the command line, but the not so crucial things like where to send mail, from what mail address to send, and S3 bucket can be provided by the command line. So that's that. And also you have to check, like, is there are these options provided on the command line, and is there a working AWS configuration already? So because Boto won't work without it. So that's what we do in here in the first step, basically in the configuration step, right after the setup of the logging. So we check for that, and then we set up two of these classes, and then we start entering our requirements, basically. So we get all the latest snapshots, have a look in here. It's basically the implementation which we already did set up in the test script. So not much to change there. Yeah, and for every of these snapshots, we basically archive and upload this snapshot. So what we do in here, we create the archive first, and basically this thing was also implemented in the backup in the test. So yeah, create send command, nothing really new here, but we do error handling, which obviously you have to do, right? So at this point, when something fails here, I figured out it is probably either you don't have ZFS at all, or you don't have sufficient privileges because you can't run ZFS send. And if the script fails at this point, I just decided to exit it and print this error message and log as well. So yeah, because there's no point in continuing on. It will probably fail for all the snapshots. Yeah, but in all cases, with the finally block, remove the file, the archive we just created. So yeah, that's the create archive part. And then the upload part is, let's go back here to the archive and upload. So yeah, after we create, we do the upload part, and one nice thing you can do is provide some metadata to S3, which is really useful. I originally intended to use something like an expires metadata, so I in the future can set up like a script which automatically destroys or like outdated archives on S3. So I don't have huge storage costs there. But I then figured out maybe it's better to just give a creation date and let the script, the other script basically, which I maybe will write anywhere in the future, figure it out if to delete it. And yeah, so I just pass a simple creation metadata key. So because Amazon S3 actually doesn't have such a thing, it has a last modified key but not a creation key. So yeah, that's what I do here, and then we try to upload the whole thing. Yeah, it's basically yeah, use the Boto API and upload the thing. And if something fails, it's actually the exception is actually implemented in another module. So if this happens, log it and erase a backup error, because at this point we can still, it's not huge, we can recover from that basically, but we have to, in all cases, remove the file, obviously. So yeah, that's the creating archive and uploading part. And basically when a backup error from the uploading gets thrown, we have our summary here, which yeah, is used to create a summary basically, and we have a simple counter for the errors occurred, which will later be integrated into the message, the summary message, right? So yeah, that's that. And then after that, we are pretty much done. We just have to remove the outdated snapshot, which is just one command. So yeah, zfSnap -d. And then then we prepare to render the actual summary. I also could have like thrown this thing into the render method, but I was like, okay, render should just should just exactly do this, render the whole thing and not do anything else. So I called it prepare to render, which gets the total bucket size of your bucket, of your S3 bucket, and checks if some errors occurred, and if they if some occurred, they it will basically just read out the log file and print the log file, send the log file all together with the mail. So yeah, really simple. And then we basically just send a mail, or maybe I should send summary mail with manual. Basically, I think this is a better term. So yeah, it's not, as you can see, it's not really nicely refactored, and there's in some methods different abstractions, different abstraction levels. Yeah, but for the first first shot, it's okay. So at this point, I will implement all the unit tests for the whole script, and then run the unit tests, yeah, and see how it goes. Okay, so a lot of time passed since I since I implemented the backup script, and also tweaked it and ran it a couple of times, but I didn't have time or motivation to finish this part of the video. So yeah, but I'll do it now. So we are on the server right here, and we run the script here with the this is exactly the same exactly the same parameters, the script, as I have it in my cron tab. Yeah, and it's basically running, and here we have the log, and it just uploaded the stream, or the snapshot, let's call it, for this ZFS file system. And now yeah, that's the next one. And yeah, so what did I change in the actual implementation? Yeah, I fixed some bugs and so on, but one thing is I use PXZ now instead of XZ, which basically is the same, but it does compression in parallel on all your CPU cores and so on, and not on a single one, which results in 3 times faster, yeah, 3 times faster execution speed. So the script runs 3 times faster. So let's see here. It currently archives one of the jails, and yeah, it started at this point, and now it's 6 minutes later, and it's already almost done, I think. Yeah, not root, home will maybe be I don't actually know how big home is, but it shouldn't be that big, right? Yeah, let's see. Yeah, but besides that, actually, mm, it didn't change much. And with like 10 to 15 minutes execution time of this backup script, I'm actually quite happy. Yeah, and so let's just wait till it's running through. Okay, so it's ready. It's currently uploading. This search jail, man. And then let's also do a to check if it actually uploaded all right. Sudo AWS S3 ls and then our bucket name. So we already have that here when the thing is done. So we're at web server now. Oh, and web server is done, and we're at home now, and home is also already uploaded. I think home is the last one. So let's see. Yeah, it finished. So let's check that this now. Let's probably locate it under here, and let's do also a oh right. Let's open my mail, and here I have a new. I just got it here. I just got it a summary from Mandrill basically, or from the not from Mandrill. Yeah, with Mandrill basically. So it tells us all our archive sizes and so on, and how big the bucket is, 3 gigabytes now. But to double check, let's do it on the command line as well. So minus minus recursive, minus minus human readable, and minus minus summarize. Yeah. Oh, okay. So it's actually not 3 gigabytes. Oh no, it is because we only look for the files under the 0 prefix. So yeah, under the 0 prefix, there's 1.6 gigabyte, and yeah, so it actually all worked fine. And yeah, that's the end of this video, I guess.